Hey guys, today we're going to talk about heat. We're going to talk about day two. So hopefully you're ready. Here we go. Okay, so what we're going to focus on today is temperature and specifically the scales. So we're going to start right off the bat with what you need to know. You're going to need to know the three measurement scales, which are Fahrenheit, Celsius, and Kelvin. Now, out of these three measurement scales, there's only two that we really use in chemistry, and that is Celsius and Kelvin. We don't really ever use Fahrenheit, um, just because it's not scientific. Kelvin comes into a lot of math questions involving chemistry and stuff like that. Celsius is just kind of what the rest of the world uses, so it's what we use as scientists. So, one of the things you're going to have to do a lot, especially when you get into like an actual chemistry class in your junior year, is you're going to have to tell the difference between Celsius and Kelvin and how to convert the two. Before I get started with that, one thing that I want to make super clear is that degrees Celsius, there's a degree sign next to Celsius, there's not a degrees next to Kelvin. We'll talk about why in a little bit, but it has to do with the fact that Kelvin is an absolute scale. Okay, so Celsius versus Kelvin. First thing you need to know is that Kelvin is going to equal whatever your Celsius temperature is plus the number 273. So let's say we were trying to find a number in Kelvin and we knew that our Celsius number was 100. This is the same thing as the boiling point of water, 100 degrees Celsius. Well, to find that in Kelvin, what we have to do is we have to take that 100 degrees Celsius and we'd have to add 273 to that number. When we do that, adding 100 to 273, we get the number 373. 373 degrees Kelvin is the same thing as 100 degrees Celsius. In case you were wondering how to go the opposite way, let's say we wanted to figure out what 100 degrees Kelvin is in Celsius. So we're going to start with Kelvin, and we're going to try to figure out how many degrees that is in degrees Celsius. What does that equal? Well, as you might have guessed, in this case, we're going to have to subtract 273 Kelvin, and our answer would be negative 173 Celsius. So, those are your two equations. Degrees Celsius is plus 273, that gets you Kelvin. And for Kelvin to Celsius, you're going to subtract the numbers. So, Kelvin is always going to be big, and Celsius will always be small. Just finish writing that out there. Here we go. Kelvin's big, Celsius is small. I would have these two equations written down. There's the second one. Sorry that it's kind of covered in pen. That's my bad. But yeah, Kelvin is Celsius plus 270 degrees. Your temperature in Celsius is just whatever your Kelvin is minus 273. So 100 Kelvin is the same thing as negative 173, and 373 Kelvin is the same thing as 100 degrees Celsius. Kelvin's always big, Celsius is always small. Moving on here, there's a couple other problems converting 0 degrees into Kelvin. Go ahead and pause the video, take a moment to do that. Great, so hopefully to get from Celsius to Kelvin, you add 273, so our number is going to be 273 Kelvin. The next problem is asking what body temperature would be in Kelvin. Go ahead and try that one. Cool, so hopefully you got 37 plus that 273 is going to give you 310 Kelvin. Hopefully by now we're feeling good about converting between degrees Celsius and Kelvin. Kelvin, remember, is not in degrees. It's just Kelvin. We're going to skip this for now. Okay. So the reason Kelvin is in Kelvin and not degrees is because Kelvin is an absolute temperature. Here's what that means. At 0 Kelvin, all motion stops. Kelvin actually, or Lord Kelvin, his name is William, but the guy who came up with the Kelvin scale actually related the temperature to the speed of the particles. remember from day one, temperature is the same thing as particle speed. Unfortunately, most of our temperature scales don't really measure particle speed. They just start 0 at a random number. For example, 0 in Celsius is where water freezes. That's not 0 movement. That's just what some dude in the 1700s decided 0 should be. So 0 Kelvin has a specific name. It's called absolute 0, meaning that there's other zeros in temperature. Kind of no one really agrees on what 0 degrees Celsius is, or zero temperature is between Celsius, Kelvin, and Fahrenheit. But at 0 Kelvin, that's when there's no temperature or no movement of particles. So I would write down that at 0 degrees Kelvin, all motion stops, and that 0 degrees Kelvin is known as absolute 0. Let's go back to the little history slide. So I think this is kind of helpful in knowing where it comes from. You don't necessarily have to write this down, but it might be helpful to listen. Fahrenheit named this temperature scale. He was a doctor back in 1724, and he came up with this scale for temperature because he wanted to know more about the human body. So you'll notice that one of the temperatures he set was at 98 degrees Fahrenheit. So he set it like right about here. And that was the temperature of an average body. So he just decided that about 100 is human body temperature. And then he set 0 degrees as the coldest solution he could find. So kind of his idea was as cold as possible, that'll be 0. But this was back in 1724. We now know things that are way, way colder than that. Celsius kind of looked at this and was like, okay, well, this works for medicine, but it doesn't really work for scientists. Let's take two things, water boiling and water freezing, and set those at 0 and 100. So we did. And that was kind of nice because people could all boil water, for example, or they could all freeze water. Versus to make this brine solution with salt water and ammonium chloride, you had to know the exact chemical formula. Or to figure out average human body temperature, you had to like sample 300 different human bodies to figure out what the average temperature was. It was easier to replicate Celsius. Kelvin came along in the 1800s, mid-1800s, and he realized that, wait a minute, he found this relationship between gases, between their volume and their temperature. And what he knew is that starting at like a volume of 1, here's what the temperature looks like. It kind of gradually increases, and as it gradually increases, the volume starts to increase. So what he figured is eventually we get to some point, some sort of temperature, 0, at which we had a certain volume of 0. Anyways, it turned out that the temperature was like way over here. Sorry, I'm just gonna, let's just undo that a little bit. Oops. Just undo that last little bit there. Anyways, he figured out that the temperature goes way back over here, and yeah, it's just super low. So he figured out absolute 0 was the point at which there would be no movement based on volume and temperature. Kind of cool. And then here, just kind of how the scales look different and how they're similar. The important thing to notice here is that none of them really match up whatsoever. So kind of crazy. But the nice thing is the ratios for Celsius are the same as the ratios for Kelvin over here. So Celsius has the same numbers, it's just everything here is added to 273. The difference between Fahrenheit and Celsius requires some complicated formula that we're not going to really get into. So be happy that you only have to convert Celsius to Kelvin. Okay, anything else that we need to talk about? Some people have wondered, are we going to get down to absolute 0? And the answer is, it's kind of tough. Here's how they tried. So kind of the idea is, here is where the sample is, that is, 0 degrees, 0 degrees Celsius, or 0 Kelvin. My bad. Now, in order to get to 0 Kelvin, you need one dot that's 0 degrees Kelvin. And then, since heat transfers from hot to cold, you need everything that's around it to also be 0 degrees Kelvin, or 0 Kelvin. Now that you've got the dot and everything around it at 0 Kelvin, you also need the other stuff that's around it to be at 0 Kelvin. And then the other stuff around it. And then the other stuff, and 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 the other stuff. you get to a point where you can't really make something 0 Kelvin because you always have heat transferring from hot to cold. So scientists have been trying to find ways with, superconductors and NMR, which is magnet stuff, and getting things into nuclear stages. And I think there's some lasers in here as well, and some super cooled liquid over here to try and get heat to flow instead of flowing from hot to cold, to get it to flow from cold to hot. But it hasn't really worked at this point, and we've gotten super, super close. 100 pico Kelvin is 0.0000000001 Kelvin. So there's like 10 zeros there. Sorry for this messy handwriting. Anyways, fun facts. Hope this helped. Hope you had a great time. Hope you learned something about temperature. Have a great rest of your day.